So we're saying that this list contains, because 14, 15, and 16 are no concept for you all to understand. Base 10 numbers. Then plus 0 times 2 to the 1, then plus 1 times 2 raised to the 0. 2 raised to the 0 is 1, so this is 1 times 1. 2 raised to the 1 is 2, look at right here. So this is actually 0 times 4, and keep that times 21. Guys, so into 1 raised to the 3 times 3. We did this 3 on 2 minus a half. Anything raised to the power of 0 is equal to 1, and anything raised to the power of 1 is that thing. We're going to take this element here and multiply. This 0 is equal to 1. So this is 1 plus a squared. We can see 1 plus 1 is 2. Now we're going to want to convert that. So let's see if we can establish that on the line. Let's go on this side. Times 10 to the positive 3. Right, so this is how the text provides it. Then we have meter cube, and we have established beforehand. So let's say we want to estimate that this 206.8 miles and divided by the amount of water that each cup holds. Let's take a look at this question. Be about 14 pounds, right? And we have 18 of them. So to multiply this 18, we look on the right hand side, which is here. This is the larger unit, so we have to take this 45 and divide it by the convolution. It's 1 centimeter square. So if we count the individual squares, 4, 5, 6, 7, 8, 9, 10, 11. Just gonna put a plus again, plus 0. Right, and then this guy and the 4 4s is 16, 8, 2 times 8 plus 2 times. As if we take the square, right, and we just rotate it at an angle like this, right? Then the perimeter of this irregular shape that in blue, this distance becomes the I times 3 squared, right? So it's 3 centimeters, 3 centimeters. So you write it as 15 centimeters. To that out. Okay, let's use a different color. Let's see if I can find a different color. Let's use purple, right? So we're gonna record that this distance here is 15 centimeters. So you can see that the area. So we take half of the 10. Which is 5. So 5 times 5 is 25. 5 was 5, 6, 7. So that's 75. Right? That's the area. Right. So we're just gonna, right? These 2 points must be connected by a straight line such that, right, the line does not pass through the center. Right? Once we meet those criteria, then this is known as a chord. Right? Now this shaded region becomes a shade this region here, right? And just write side of the area of the sector in this case is going to be 3.142 centimeters squared. Okay guys, you could write that. Okay, that's it right there. Right? This which is in front here. That is also one component of the total surface, as you guys can see. Now let's see this piece on top. We're not going to give that one a color. Let's just write it in blue like this. That surface there, that entire surface there. Right? Let's see this one here, we're gonna write it in, and let's say we do sharp green, right? This gives us a next surface, right? And you can see one surface remains. And let's see if we can this dimension would be. So what we'd have is a face that is determined by a length and a height value. The length here, right? Now these would be the same, and all these lengths, this length and this length would be the same. Likewise, in the back here would be the same. All these dimensions. This dimension is also going to be from here to here, right? So that's the length dimension. The height dimension is going to be all the way around A, G, F, and B. And we could kind of just, and we're going to name it in a different color, right? So it's the top. So it's A, G, F, and B. Right? So we'll have 6 is 36 times 4. It's 4 times 36 times pi. Right? And remember this 36 is going to carry, going to have this radius here to be equal to 6 centimeters. Going to have this length here to be equal to 18 centimeters. And the area of the square could just be given, maybe a like that. Right? So we can see that the surface area is a half plus E. So it's E plus a half PS, right into this ultimate expression of, right, and 5 cubed is 25 centimeters cubed, right? So that's it. How the input, right, becomes mapped to the output. So let's say for instance A, right, for this one input value, we could get it corresponding to 1 on the output side. We could also get that same input value corresponding to 2 on the output side, like that. We could get B corresponding to 3, right? B mapped to 3 in that sense. D being mapped to 4, and C also being mapped to 4, right? What is happening here, where a single input is being mapped what arithmetic or operation is being performed on the inputs in order to translate into output, right? So we leave in this section blank, right? So we have input again and we have output, right? So let's say for argument's sake we have 1, 9 and 0, right? We can see here that the 9, right, has two mappings, which makes this not a function. To describe this mapping based on the formal rules of what defines a function, we could see that in the green, these two types of mappings are regarded as functions. Identify with what a function is, right? What a relation is, and we said that functions are a subset of relations, right? Because relations is just a relationship between input and output values, right? Irrespective of what formal rules or arithmetic is being applied. Powerful to do so. Positive 2. Make sure I write. Let's see if I can. Right, so we have just proven that to identify now the region where x plus y is greater than or equal to 6. Right, we have to start from this line and move in this direction. Right, that represents the x plus y is greater than 6 region. Okay, so let's do that in blue. Let's get the blue. Right. And we say we starting from the line, okay? We incorporating that line, okay? And we just shading that. So we say this region is the region that satisfies all the criteria. So we just draw a line here, and we see it satisfies all these criteria. Yeah. So I drew the line in the wrong place. The line's supposed to be here, right? So we see it satisfies, that region satisfies all these criteria at the same time. Yeah. So that is a open bracket x plus h all squared plus q ah squared. To go from solving is very simple. On this side, right, going back to know that the roots is going to be x equal 1 and x. The way how, right, x squared minus 3x plus 2, right? So what we do, we take the coefficient of the x, which we know is equal to 1, so a is equal to 1, and then the c value, c is equal to 2. We know b is equal to minus 3, right? So we take this 1 and multiply that 2. So we say 1 times 2 is equal to positive 2. And then we find the factors of positive 2. Negative 1 is less than or equal to x, which is less than or equal to 1, right? So that is literally negative 1, 0, and 1. If we test this interval, then when we try the 1, when we substitute the 1 in the function, we're going to get 0. So we're going to know that x is equal to 1 is a factor. Right? Once we know a factor, then we could use the long division, which becomes the fourth method, right? So we're going to write method number 4, graph. And this is put, and when we put 2 in the equation, 2 squared minus 3 times 2 plus 2 is 4 minus 6 plus 2. So, right, indeed we get 0, right? So we put the 0 here as well, right? So now we have one more thing, 3 on the x, 2 on the y. Let's see that 3 on the x, 3 on the x, 2 on the y is right like this, right? That's what we're seeing, but we can't actually identify with that point, right? Let's see if I could improve on the shape of that graph. Symmetry. Look at that. You would have cut the curve in 2 equal portions. So this is known as the axis of symmetry. So that's the same graph from, and remember we know beforehand that a must be positive in order for us to get a minimum point. Let's take a look at something very, very important. Graph of, title of the graph, sorry, graph of x squared plus 6x plus 5 within the domain of what? X's range from 0 to minus 5. 0 is less than or equal to x, which is less than, actually let's do it. Yes. Minus 5 is less than or equal to all squared minus 0, 4, right? X plus 3 all squared minus 4. Okay, so the only reason why we need it, when we identify the roots, we then expand to get quadratic, and from the quadratic we know what the a value is. The output of the function becomes the input of the input. So we can see when we take a look at what is happening with 3. A's represent these dotted lines, and we will have a triangle, and here we will have point, and that point is 4 on the x. Let's say the function looks something like this. Let's say the curve looks something like this. With a curve looking something like this, we could see that if we move our line to this point, right, and let's say that value of x is where x is equal to intersecting the curve multiple times, right? You can see it, guys. If you move it here, we can see that it interacts right there and right there, right? If we move it to a position further to the right, we're going to see it's the same thing that happens, right? It interacts right there and right there, right? So you can see this curve fails the line test, okay? Let's take a look at next instance where a curve would fail a line test, okay, it would have failed the horizontal line test, right? So we write here failed, and if it does, it means that the inverse of this function, whatever function is producing this curve, the inverse, right? So we know that this angle here is also 45 degrees, right? We could see that the intercept is 2. This is the y-intercept for this line is 2. Y-intercept. We can be certain that if we were supposed to write this straight line as a function, y is equal to mx plus c, we know beforehand that the intercept is 2. Okay? The same angle. It makes the same 45 degrees with the horizontal. So this line is going to be y is equal to, right? Tan 45 is 1, so that is 1 times x. It's just x alone. Plus, and the intercept is going to be 3. You can see the intercept here is 3, right? We're just going to mark that plus 3, right? So y is equal to x plus 3. That would be, so I'm able to move it, but moving along with that line. Okay, I'm moving this thing out of position. Let's see how, yeah, so I think I should, yeah. Right, so we are able to move it, right, to look like greater than 5. They must exist within this range. And the range that we identify with is, right, just not 2, so it could be slightly a fraction less than 2, right? So we could write a dotted line here to show that it doesn't include that, and write a line here to show that it does include the 5, right? So this is the region that we are concerned with. See it, guys? So long as it's not equal to 3, okay? Then the answer we get is not going to equal to 9 if we put negative remains true. Let's take a look at the reverse. So I'm going to erase that, right? So we started out with this guy, which is also less than. And that does it, right? You guys would have had the superior understanding of this phenomenon, this topic. Once we continue to identify where this line continues, so let's say for instance the line y is greater than x plus 2 and y is greater than or equal to x. That's it. It satisfies both. Okay, once we've identified where y is equal to 1, we can find the region where y is now greater than or equal to 1. So y being greater than or equal to 1 has to be what number when added to 1 1/3 gives 2, right? So we have 1 already, we have a third. What we're missing now is 2 over 3, right? How we know that? 1 over 3 plus 2 over 3 is going to give us, right, common denominator plus 1. 1 plus 2 gives us 3, right? This 3 over 3 would equate to 1, right, to add to that first one. Okay, so that's how we know that we have a 2 over 3 that is missing, right? 1 and 1 over 3 tells us that x is equal to 4. And actually 4 is the minimum, it's not the maximum, right? So you want to make that clear. This formula, as it is only with respect to calculating in 0.7, and that gives us 126, right? Right, this could have been, you could have worked this out, 180, 0.70, okay, but 2 placeholders like that, and then you can multiply. You can also remove the placeholders and just put 0.7 like this. So 7 zeros 0, 7 8 is 48, 7 1 is 7 plus 4 is 11. Then there's only a 0 here, so you can see that